We're now going to move to finding the surface area of cones. Now cones, basically just like a pyramid, they're a pyramid that have a round bottom, but they have a special name. It's called a cone. To find the surface area of it, we need to know the dimensions along the outside. Again, we need to find the slant height of the cone. If it's given to us, our job is easy. If it's not given to us, we're going to need to use Pythagoras in this right triangle that's created with the height and the radius to find it, just like we did in our pyramids. The formula for surface area of a cone is pi r squared plus pi rs. And again, this looks similar to the surface area for a cylinder, where the cylinder had a pi r squared and a 2 pi r h, but this has this part, which we should recognize the area of the circle. So this is the circle base. So if we're finding the surface area, this is telling us the area of the base of this cone. And this right here is telling us all that stuff wrapped around the circle, or it's basically telling us our lateral area. So like in any question, it's going to come down to how you read the question. Is it asking for the surface area of the entire cone, including the bottom? Is it asking just for the lateral area, the stuff around the edge? And you have to determine, does the question give me my slant height? If I'm finding surface area, that means I'm dealing on the surface of this cone. I need the dimensions on the surface. So let's read the first question and see what's going on. Let's find the surface area of a cone that has a radius of 12 feet and a slant height of 15 feet. So you probably want to start this with just a simple diagram. So to draw a cone, we got here, circular base. Try to draw the circle that we don't see. And then right from the middle of the circle on the bottom, it's telling us I have a radius of 12 feet. So from the center out, that's 12 feet. And the slant height, so the slant height is along the edge of the cone, the slant height is 15 feet. So as I said earlier, I have the radius, the slant height, I have everything I need to find the surface area. So we'll start with the formula, which is surface area is pi r squared plus pi rs. Surface area, we have pi times the radius, which is 12, squared, remember that means 12 times 12, plus pi times the radius, 12, times the slant height, which is 15. And I'd probably do these two things separately and then add them up in the end. So we will look on our calculator to see what this looks like. So we want to do the first part first. Pi times 12 squared, or pi times 12 times 12. That gives me 452, and if I round to one decimal place, 452.4. So 452.4. That's the area just of the circle on the bottom of this cone. And now the lateral area, I'm going to go pi times 12, which is the radius, times the slant height, and that's 565.5 rounded to one decimal place, 565.5. Now this tells us the area of just the stuff around the edge, or the lateral area. The combined surface area of this cone is the sum of those two. So 452.4 plus 565.5 gives me a surface area of 1,017.9 square feet. So again, if we have the slant height, our job's pretty easy. If it told us our diameter, we're going to have to take half of it to find the radius. So you have to read the question and you have to determine, does it want the whole surface area or just the lateral area? So let's look at this example. It says find the surface area of this cone. Now we need the slant height, we need the radius in order to find this. So if we examine the question, we could say, okay, 4.6, that's the diameter across. So what's the radius going to be? Or sorry, that says 9.6. I take half of 9.6. 9.6 divided by 2 tells me that I have 4.8 as my radius. So 4.8 from the middle out. The slant height, unfortunately, is not given to us, but it does tell us we have a height down the middle of here of 12.8, and I have the distance across there to be 4.8. So this is just a right triangle. And again, I like taking these triangles out and looking at them separately. So here's the 4.8. Here is the 12.8 for the height of the cone. And then I got a right angle here. I'm trying to find this side. We just used Pythagoras to figure it out. So we're going to take 4.8 squared plus 12.8 squared. That'll equal c squared. Because remember, Pythagoras is a squared plus b squared equals the hypotenuse squared. So if I square those and add them up, again, I'll show this on the calculator, 12.8 squared plus 4.8 squared equals 186.88. So 186.88 is the hypotenuse squared. So I need to take the square root of 186.88. So in our calculator, square root 186.88 gives me, we'll round to one decimal place, 13.7. So the hypotenuse of this triangle is 13.7 centimeters, which in our diagram actually gives us our slant height, which is 13.7. So now I have the radius and I have the slant height. I can go through and find the surface area. Surface area of a cone is pi r squared for the bottom plus pi r s for the lateral area. Now I read the question again, it's just saying find the surface area of the cone. It doesn't say just the lateral, so I need the bottom as well. So this is why this formula works. If it said just find the lateral area, we ignore this altogether. So let's put in the information that we do know. We got pi times the radius, which is 4.8 squared, plus pi times the radius times this slant height we found of 13.7. Again, I'd probably do the pieces separately. And I've done the calculations ahead of time. So pi times 4.8 squared gives us 72.4. Plus the lateral area now, pi times 4.8 times 13.7 is 206.6. Having both of those rounded to one decimal place. So if I take the area of the bottom and add it to the lateral area, that's the complete surface area of this cone. So the sum of those two parts is 279, and in our case, square centimeters. So don't forget, if we're finding surface area, we need to have the slant height. We need the height along the edge of the cone. We also need the radius. And you need to read the question to make sure what it's specifically asking for. If it's asking for the entire surface area or just the lateral area of the cone. And if it is, we have to adjust our formula accordingly.